আজকে আমরা রোটেশনাল মোশন মানে ঘূর্ণন গতির কিছু প্রবলেম নিয়ে ডিসকাস করব। ফার্স্ট যেটা নিয়ে আমরা ডিসকাস করতে চাইছি যে সাপোজ এখানে সলিড স্ফিয়ারের একটা সেগমেন্ট, এই সলিড স্ফিয়ারের একটা সেগমেন্ট যেটা রেডিয়াস ধরে নিলাম r/2। আমরা এই সলিড স্ফিয়ারের মোমেন্ট অফ ইনার্শিয়া ক্যালকুলেট করব। এই যে সেগমেন্ট অফ সলিড স্ফিয়ার যেটার মাস আমি ক্যাপিটাল M কনসিডার করে নিচ্ছি, এটার আমি মোমেন্ট অফ ইনার্শিয়া ক্যালকুলেট করব। তো the solid sphere is generated by revolving circle about the diameter. তো মাস অফ দ্য সেগমেন্ট, আমাকে এই সেগমেন্টের মোমেন্ট অফ ইনার্শিয়া ক্যালকুলেট করতে হবে। তো মাস অফ দ্য সেগমেন্ট, mass of the segment m, that equals to density into volume of the segment. Now consider a small disk of radius y and thickness dx. Here consider a small disk of radius y and let the thickness be dx and distance of this disk from the center, let that equals to x. Here the radius is r. Now mass of the small disk dm, mass of the small disk dm, that equals to rho into pi y square into dx, where rho is suppose density of the solid sphere. So rho equals to m by v, that means m by integration of pi y square dx, limit is r/2 to r. So that equals to, here according to the diagram, y square equals to r square minus x square. Now put the value here, m by integration of r/2 to r, pi into r square minus x square dx. By calculating this, we get the value of rho as m by 5 pi r cube by 24. That means 24m by 5 pi r cube. This is the value of density. Now moment of inertia of the disk about x-axis, that is di, that is half into dm into y square. Value of dm টা ছিল rho pi y square into dx. So I equals to integration of di, that is half rho into pi into integration of y to the power 4 dx, limit is r/2 to r. Now we know that y square equals to r square minus x square. So by this we get the value as r square minus x square whole square dx. Now on calculating this, we get the value of I, that equals to 24 pi m by 10 pi r cube into r to the power 4x minus 2r square x cube by 3 plus x to the power 5 by 5. Upper limit is r and lower limit is r by 2. Now solving this, we get I equals to 53 by 200 into mr square. This is moment of inertia of the segment of the solid sphere. Now আমার second question, second একটা problem. একটা বডি যেটা কম্পোজড হয়েছে একটা কোন আর একটা হেমিস্ফিয়ারকে দিয়ে, রেডিয়াস স্মল আর কনসিডার করে নাও। হেমিস্ফিয়ারটা বেসের সাথে কন্ট্যাক্টে আছে। Now we have to find the maximum height of the cone so that the combined body may stand upright. We have to find out the maximum height of the cone so that the combined body may stand upright. Now here, the composite body is symmetrical about y-axis. Therefore, its center of gravity will lie on this axis. Now consider two parts of the body, hemisphere and cone. Let the bottom of the hemisphere be the axis of reference. This radius is r and let the height be h. This is x-axis, this is y-axis. Now here weight of the hemisphere W1, that equals to rho into g into 2 pi r cube by 3. Now distance of center of gravity of hemisphere from the bottom. Distance of center of gravity of the hemisphere from the bottom, let y1, that equals to 5r by 8. Now weight of the cone, that is rho g into pi r square by h by 3. Now distance of center of gravity of the cone from the bottom, y2, that equals to r plus h by 4. So center of gravity of the combined body, that equals to w1 y1 plus w2 y2 by w1 plus w2. Now by putting these values, we get rho g into 5r by 8 plus 1/3 rho g pi r square h into r plus h by 4 divided by rho g into rho g into 1 by 3 into pi r square h. Now for stable equilibrium, y must be less than equals to r. That means the value of y must be less than equals to r, then h square must less than equals to 3r square. That means h must be less than equals to 1.732r. The maximum value of height of the cone, that is 1.732 into r. Next problem. Here the mass of block A is twice the block B. We have to find out the acceleration of A in terms of gravitational acceleration, and here neglect the mass of pulleys shown in the figure. Neglect the mass of the pulleys. So the free body diagram of this system is like that. Consider here the height is y1. Here the height is y2. Here the length is L. Here the acceleration is A1. This is mg. Suppose this is 2 mg. Here is A2. Here the tension is T. So equation of motion for body A is 2 mg minus T, that equals to 2m into A2. This is equation number 1. And equation of motion for body B is 2t minus mg, that equals to m into A1. This is equation number 2. Now here, suppose length of the rope is L, and that equals to y1 plus y1 minus L plus y2 minus L plus 2 into half of the circumference. Half of circumference. Or here 2y1 plus y2, that equals to constant. Now differentiating twice with respect to t, we get 2 into d2y1 dt square plus d2y2 dt square, that equals to 0. That means 2a1 plus a2, that equals to 0. That means acceleration of body A is twice the acceleration of body B. So from equation 1, 2mg minus t, that equals to 2ma2, that equals to 4ma1, because acceleration of body A is twice the acceleration of body B. This is equation number 3. Now on solving equation 2 and equation 3, we get A1 equals to g by 3 and A2 equals to 2a1, that is 2g by 3. That means acceleration of body A, that equals to 2g by 3. Here is a next question. Here is a homogeneous slider bar of mass 4 kg and length 500 millimeter being pushed by a force of 60 Newton along a smooth horizontal surface. Determine the angle theta for translation. We have to find out the angle theta for translation. So here the free body diagram of the slider bar. Here the weight is 4g. Here the acceleration is A. Here the reaction forces. Suppose this is point A, this is point B. Let here the reaction forces RA. Now here angular acceleration alpha equals to 0, and let linear acceleration that equals to A. Now here the total horizontal force that equals to ma. That means 60 equals to 4a. So a equals to 15 meter per second square. And vertical force here, that equals to 0. So RA minus 4G, that equals to 0. So RA equals to 4 into 9.8. That means 39.2 Newton. Now, taking the moment about this point G, we get 60 into 0.25 sine theta, that equals to RA into 0.25 cos theta. So tan theta, that equals to RA by 60. Now on calculating this, we get this equals to 0.654. So theta equals to tan inverse of 0.654. Now this is total clockwise moment equals to total anti-clockwise moment. Here applying the moment about point G.